Suppose you've watched a chemical reaction and you'd like to report how fast it's occurring. This can be an important thing in a lot of processes. In this screencast, we'll learn how to measure the rate of a reaction. That means we will measure the rate of a chemical reaction, show you how to do it, show you the formula that's involved. We'll think a little bit deeper and we'll ask ourselves, is there just one number for that rate of a reaction? Like a car might be driving at 65 miles per hour, that's one number? Or is there more to it than that? And what final units might make sense? Is it miles per... No, it can't be that. It must be some special units that are used for the rate of a chemical reaction. This is Screencast 13.2, and let us begin. How do we measure it? Let's imagine A turning into B, which, by the way, I think is impossible. I don't think that is a chemical reaction. That is simply... could be a nuclear process, but I can't imagine that being a chemical reaction. In any event, it makes a good starting point for our theoretical consideration. What's going on when a chemical reaction occurs? In terms of rate, well, the reaction concentration has got to be going down. You're getting rid of A, and you're making some of B, so the product concentration is increasing. And if you're talking about rate, if you think about it as speed, that might help, because it's just like the rate of anything else. Imagine driving a car. It's the change over time. For a car, that would be miles per hour, but you're not covering any distance in a chemical reaction. You're changing the concentrations of things. So it must be the change in concentration over the change in time. But should you pick starting material, or should you pick product? Well, let's talk about the units for a minute. The units should be concentration. Typically it's moles per liter, for which we always use the square brackets. For time it can be seconds, minutes, hours, whatever you like. It doesn't really matter whether you're talking about the disappearance of A or the appearance of B. You just have to specify what it's for. And many chemical reactions include lots of reactants, lots of products, and don't forget they can be in ratios that are not 1-to-1. So typically people talk about chemical reactions. They say this reaction rate is occurring at a certain moles per liter per second. Notice that would be the final units that kick out. Notice that's exactly the same as saying molar per second, or if it turned out to be that molar per minute. And one other final thing to consider is that the chemical reaction rate is not steady over time, just like driving a car is not steady over time. There's acceleration, there's deceleration, you might stop to get a cup of coffee, things like that. So you have to be careful about what you're referring to when you talk about the rate of a chemical reaction. And that's how we measure it.